All right, so I guess we'll take advantage of the extra time we got from the keynote getting out early. Thanks everybody for coming out. I'm Jay Thrash. This is a continuation of a talk I gave last year on the topic of being better stewards of our application architecture and techniques that we can apply to make our intentions known when we're building apps. But before I get into the meat of the topic, I want to congratulate you. You survived another 360i day. But it is the last day, so maybe you're feeling a little bit like this. So once I found out that I was speaking on the last group session on the last day, I tweaked my talk a little bit. I scaled back on, I didn't want to throw a lot of code in your face and stuff like that. So hopefully this talk will be something that you can mull over in your heads as you're heading back to all the various places that you are visiting from. So once again, thanks for sticking it out and hanging in here with me to the very last session. All right, so good intentions 2. I have to remind myself to breathe. For each of these, I took that just a few minutes ago. Heart rate's a little high. All right, so intention. This is, 2 years in a row that I've used this word in my talk. So there must be something about this word that is important to me. What do I mean by intention? Well, you look it up, intention, it's very simple. A thing intended, an aim or a plan. I really like this part of it, an aim or a plan. It's going into something with a purpose, with an attitude of not just slinging some code, but really understanding what it is you're trying to accomplish. And in my case, I feel like we need to be building our architectures with more intention. We need our architectures to reflect the decisions and the intentions we have and not necessarily be limited to kind of the cookie cutter patterns of MVC or MVVM or any of the other, hot architectures of the day. We should really be using those as more of an implementation detail rather than something that truly wields power over our overall architectures. So what's our biggest challenge as developers? I think it's fighting ambiguity, because we might come up with an idea, a solution for something that seems like it's kind of a clever way of doing it now, but over time, that solution becomes more and more ambiguous. Am I going to remember why I implemented something the way I did a day from now, a week from now, or a month from now? Somebody else comes on the team, are they going to understand why I implemented it the way I did? So I don't want us to be ambiguous. I want us to be obvious. I want us to be intentional in the way that we build our applications. So like I said, this is a continuation of a talk that I gave last year. If you want to go look it up, there are copies of it online. Back then, the one I did last year was specifically about pulling responsibilities out of your view controllers that probably shouldn't have been there in the first place. And I followed kind of 3 key techniques. I defined this concept of a store, which is encapsulated access to kind of shared resources that can be used throughout your application. Being a delegate, not being a delegate now, but delegate as a verb. Okay, delegate. Put those responsibilities elsewhere. Get them out of your view controllers and make someone else do the work for you. And by pulling it out somewhere else, it's probably going to be easier to test because it doesn't have all the baggage of standing up a view controller just to test some functionality. And then finally, I talked about intentions, and last year, intentions was the word for like encapsulating view logic alongside of your actual views and not necessarily having to put those in your view controllers and being able to use those intention classes throughout the application. This year, I'm going to tackle a new topic of state, and specifically, how do we manage state with intent? And what do I mean by that? Well, I think in a lot of our applications, we tend to think of state just in terms of its very kind of minute values, right? States can be encapsulated using bools or maybe enumerated values. But over time, you'll find that you'll run into limitations very quickly if these are the only ways that you're trying to maintain state within your applications. Bools, they're the lightest weight thing out there. They're easy to start, but they really only support a very minimal number of states. Once you've got something that needs to maintain multiple states, you're going to run into conflicts, because now when you want to transition from one state to another, you're going to have to make sure that all of your kind of Boolean values stay in sync, or otherwise you might end up in an ambiguous state where a couple of flags are enabled. Now you don't know, well, which one is the one true value. Well, I think the next logical way to combat that is to use enums, enumerated values, because those will get rid of your conflicts, because now you can define a very finite number of states, which is great. But I don't think it goes far enough, because I think that the problem with enums is that now you have control over the states, but you don't have control over how you move between the states. You know, the enums are just the values themselves. They don't dictate which transitions are valid if I go from one enumeration to another. You know, with just enums, I can go from any to any and not necessarily understand the consequences of doing that. So in my mind, I feel like these two are just too ambiguous. We need something else to solve that problem, and I think the solution to that problem, something that's been around for a long time. This might not be something we've used lately because it's not, you know, sexy new technology. It's state machines. It's about as basic as it gets, right? Now, state machines are an artifact, ancient artifact from the sands of computing history. You know, back when debugging issues looked like this, solid state memory looked like that, we had state machines. And there's a lot of things that we could learn from back then that we could pull into the way that we build our applications today. Now, what is a state machine for those of you that may not be familiar? It's pretty simple. It's a way of modeling logic. A state machine can be one of a finite number of states, and I've highlighted the key features, the key items here. So it's a finite number of states. The machine is only in one state at a time, and the state that it's in at any given time is its current state. So these are the kind of the three key features that you want to make sure that you support if you ever implement a state machine. It's got a finite number of states. It can only be in one of those states at any given time, and there's got to be a way of querying or maintaining or changing what the current state is. Now, if you want to represent that visually, you've got like a directed graph. So you've got states. You've got the concept of a current state. So one of these is my current state. And then you define the transitions between those states. So in this particular example, it's not valid for me to go from this state to that state. I can only follow the states that have been defined. Pretty simple enough. So this is state machines in the abstract. Let's get a little practical. What characteristics when we're implementing state machines should we consider? And I think that a great example of a state machine that you can actually dig into and use today was introduced last year at WWDC. There was this great session. If you haven't seen it, I highly, highly recommend it. Advanced user interfaces with collection views. Now, the majority of this talk wasn't necessarily about state machines. It was about, it was one of the few topics that Apple, or talks that Apple has ever done at WWDC, where they actually kind of spoke about their approach to application architecture. And specifically, they covered some of the key concepts they implemented while building the iTunes Connect application. And a lot of the things they covered are really more specific to the how they manage the collection views and how they build the data sources for those collection views. But buried within this topic was a little gem called Apple State Machine. And they use the state machine, the kind of the abstract instance of the state machine, to control a whole multitude of things within the application itself. So it's a very flexible concept that you can use in your apps. And there were 4 things that I really liked about the way that this particular implementation worked, and I've actually been using it a lot in some of the apps that I've worked on. It's very simple to configure. The way that they've kind of defined the transition logic, it's almost like its own little DSL, its own little domain-specific language. Near and dear to my heart, it conforms to SRP, single responsibility principle. So the state machine, all it cares about is maintaining state and the transitions between those states. It's not concerned with the repercussions or what happens as a result of changing state. That's somebody else's responsibility. And by the combination of these things, it actually helps facilitate automated testing, because now you've got kind of the logical representation of the changing of state in your application in something that's not tied to, necessarily directly tied to, say, view logic or network logic or something like that. Simple configuration, what do I mean by that? Well, the way that states are defined are just string constants. And you might think, well, you know, just a minute ago you said enums were a good way of doing this. Yeah, I would think so too, but as we'll see in a minute, because they're using strings to define the states, there's some really interesting dynamic behavior that we can pull out of that, and it's something that you wouldn't necessarily be able to do with enums. Transitions are defined as a dictionary. The keys in the dictionary are the states, and the values in the dictionary is an array, and that array defines the other states that I can transition to when I'm in one of these given states. So by looking at this dictionary, I can very quickly see that if I'm in, say, the content loaded state, that the only other states I can go to are refresh content, no content, or an error state. I can't go from content loaded state to, say, the initial state or something like that. This is great. There's one place I can go to very quickly understand the rules that define a particular state machine. Now, what do I mean about this DSL logic? So let's say that I just highlighted one of the states from that previous list of states, and I want to change to that state. So I've got my state machine, and I'm setting the current state to be that string, that variable name. But then down inside of the delegate for the state machine, the way that they've constructed this class is that it will actually inspect the delegate to see if it responds to selectors that match the pattern of did enter state value, did exit state value. And so this is the way that I can implement the logic that gets triggered when my state changes. I don't have to come up with some big, say, switch statement or some big if-else statement where I'm doing all these string comparisons. I can do this right here in the actual naming of my class methods. And it makes it really compact, makes it very obvious what the responsibility of these methods are. So it's a great way to do that. And that's what you get as a result of the states being strings instead of, say, enums. And finally, conforms to SRP, and just as a very rough diagram of how the system works, you've got a class that instantiates a state machine, and then it or some other object is going to conform to, or configure the state machine with its states and with its transitions, and it's going to conform to the delegate. And the delegate's responsibility is to react to changes in the state machine. So the object owning the state machine is going to request a change. All the state machine is responsible for is validating my request to make sure that this person, that the code is asking to go from the state it's trying to transition to as a valid destination state, and then initiate the callback logic into the delegate. So it's a great separation of concerns there. So, as a result of the combination of all of these, I think that it's just great because it helps me be more obvious when it comes to implementing logic within my application. So now we've got a state machine that can perform the tasks and responsibilities we want it to. What are the ways that we can kind of apply it within our application? And today I'm going to cover three things that I've been using it for within my applications, things that before were a little bit hairy to try to implement using kind of the standard way of doing things. Specifically async data sources, so data sources that are tied to some external resource like a network connection. Branching navigation, so one of the features of the application, and I'll go over an example in a minute, we get to a point where it's not a traditional simple stack. Based on what the user enters, there are different paths that the navigation can go down, and there are also like back navigation paths that kind of can go from anywhere to anywhere within the navigation stack. So it's really difficult to do that in the traditional like navigation controller sense of the word. And then finally, session management. So if you've got an app that requires the user to, say, authenticate or something like that, you're always going to have to juggle this thing where the app is in one of several states where it's either the user's unauthenticated, they're in the process of being authenticated, and now that they're finally authenticated, then they can actually use the application, right? So how do you maintain that logic without having to spread it all over your app architecture? Okay, so the first one, the data source. And this is an example that's coming straight out of the sample code from Apple's talk, and it's something that has worked well for me in our application. All right, so here's our problem. We've got a screen that's backed by an async data source. The user loads that view, and it goes into a state where it's loading data, so I have to represent that to the user. At some point later, the data shows up, so now the data source can update itself and then thereby update the view that it's in, whether it's a table view or a content or a collection view. Some point later, the user might want to refresh. So now I'm in a state where I have data, but I'm now refreshing and looking for more data. And then God forbid something go wrong, like I lose my network connection. How do I react to that? How do I maintain and juggle all of these states without having to pollute my data source with a lot of kind of cumbersome logic? Well, I'm going to define a state machine. And so here's what my state machine looks like visually. I start off in an initial state where I can set up some base values, so to speak. From there, the only place I can go is to load content. And then after loading content, I'm then going to end up in one of three states. I'll either have no content, I'll have some content loaded that I can display, or there might be an error. All three of those states allow me to transition into the refresh state. So if I have no content, or I do have content, or I'm in an error state, I can always refresh. And refresh can go back to any of those. But it's interesting to note that I can't say go from refresh content back to loading content. I can't go from content loaded back to loading content. Like this graph defines the states that my application is allowed to transition between. All right, let's see that in action. So I launch, I'm in the initial state, so the user navigates to my screen. I'm loading content. So when I'm in the loading content state, that's when I'm displaying like a spinner placeholder in my view. At some point later, the network request succeeds. I have data, so I'm going to update my table view or collection view and tell it, okay, here's how many items you have, here's how tall they are, all the, the details of how you populate one of those. Some point later, the user decides they want to refresh. They pull down. I'm now in a state where I have to show the refresh spinner. And then at that point, let's say something went wrong, and that's where I transition into the error state. And from there, they could pull down again and refresh if they wanted to. But we can see that with just these 5 states, I've fully defined a state machine that can handle all of the necessary functionality I need in this particular data source. So it's very compact, it's very easy to maintain. It's very, when you look at the code for the data source, you're not looking at something where it's constantly having to check states all over the place. It only has to implement those delegate callbacks as it transitions between these states. And like I said, for an example of this, you can go look at the source code or the sample code from that WWDC talk last year. All right, branching navigation. So this was a problem that was specific to an app that I was working on. It might not necessarily be something that you've run into, but if you have, then you'll understand the kind of the pain I was going through. So I met with our product owner, and he was describing, okay, look, we've got the ability to request appointments within this medical application. And the way it's done now is fine, but we actually have some customers who have the ability to schedule what's called direct requests. So they will give us the ability to kind of look into their calendar, see when there are openings, and then you as a patient can grab a slot and say, this is when I want to meet, versus just indirect scheduling, which is, hey, I'm available on Tuesdays and Thursdays between 2 and 6, and then a human somewhere at the back office has to get that request, find a slot that fits your needs, and then email you back. So the way that we did scheduling had these very two distinct paths, and depending on which path you went down, whether it was direct or indirect, it would have some kind of big consequences on the UI that was displayed. Because the direct scheduling had to have screens that would let you pick dates that you wanted to search on, go contact the external system, wait for the response. You're provided with a list of matches, then you select one. Whereas indirect is simply you filling out a form saying, you know, which days of the week am I available, how far into the future am I available, and then what time of day am I available. And what really complicated this was, not only was it branching, so based on which, say, doctor and provider and appointment type I pick determines which way I go, but as you go further and further down this stack, there are options to let the user come all the way back to the beginning, right? So now you've got this stack that you can essentially almost jump from anywhere to anywhere else. And trying to do that with a traditional like navigation controller it's got very hairy very quickly. So the solution that we came up with was to encapsulate this concept of an appointment request, which just held the data associated with the request, like which organization, which doctor, what type of appointment, and then the depending on whether it was direct or indirect, the actual appointment reservation data itself. And then as far as the view controller was constructed, we broke that down into like a wizard type view. So you've got a control at the top that indicates how far along you are in the request. There's a button at the bottom to let you jump to the next step. And then in the middle, we embed various view controllers based on where you are in the reservation process. So in this case, let me go back. So here we are at the very beginning, right? In this step, the user hasn't fully selected who they want to meet with. Then they go through the various steps to do that. They pick their org, they pick their provider, they pick the type. Once they've entered that, once they've declared that or specified that much data, they're ready. We indicate that they're ready to go to the next step. And then depending on what they've selected here, it's going to dictate what happens next. So in this case, they might go to a direct scheduling screen, or they might not. They might go to indirect. So, okay, this might look a little crazy, but this was the state machine that we came up with that allows us to maintain all of that. And it looks a little, like I said, it looks a little crazy here, but it actually is much better than trying to do this manually. And what makes this state machine a little bit complex in the number of transitions there are was what I mentioned before, which is pretty much no matter where you are in the reservation process, you have the ability to go back to the very beginning, like to the step where you pick who your doctor is and who where the appointment's going to be. But as you go down, you see that once I have this, once I define whom I'm going to meet with, and this is valid, and the valid states are basically the state. Once I enter that state, that indicates that the next button is active. Okay. So when I'm here, I only have two places I can go. I can either go down the direct search path or the indirect search path. And it's up to my wizard, my my appointment wizard. It inspects the data when I'm in the whom valid state. It inspects the data to see what type of appointment has been requested, and then we'll choose between one of these two transitions. And then once you're on one of these appointment paths, then that's going to dictate the types of screens that show up. So you'll do your search. Once the search results become valid, the next step appears. You choose a date, and then you specify your reasons. And at the very end of each one, this is kind of the end state where your appointment reason has been fully defined, and it's ready to be submitted to the system. So I'm going to step through some of this, but I'm not going to go through the whole thing like I did for the data source. I'm only going to pull out a small part because I know this is pretty complex to try to go through on the screen. So let's just go through what it takes to get through the first stage and how it is represented in the view. So I initialize and I immediately go into the whom state, which indicates that the user has not fully specified who they want to meet with and where they want that appointment to take place. They go through the machinations of selecting that, and then the wizard transitions into a whom valid state. And once they're in this state, his next button is active. And then depending on the type of appointment that's been selected, the next state might be direct search, or it might be indirect. And as you can see, the indirect state, it in addition has its own, it goes into a state where you have to define the time slots you want to meet, and until you define at least one time slot, you can't continue. So this whole kind of toggling or jumping back and forth between I'm in a state, I need to define data, I've defined that data, I'm now valid. Once I'm valid, I can jump to the next state. How much do I need to define? Am I valid? Okay, I can jump to the next state. And once it's important to know that these two states you can cycle between, because I might go in and pick a provider and then realize, oh wait, no, that's the wrong doctor, I need to pick a different doctor. And so now I'm going back and making changes. So I'm going to go from a state where I might have been valid back to one where I'm not, because I haven't fully defined who or where I want that appointment to be. All right, so I don't expect you to read this all the way in the back of the room, but I'm just showing this to you as a way of just indicating that all of the states and the entire state machine for this whole system, which comprises, I don't know, a dozen or so screens, is all defined in one place in the application. It's this one dictionary that's got like 12 entries in it. So anyone else who comes along after me to try to maintain this, they've got one true source of knowledge to go to try to understand how do all the screens flow between each other. If I need to add new functionality, is that functionality currently supported by this state machine, or do we need to modify that state machine? And you don't have to worry about trying to spread all this functionality across your view controllers, and then all your view controllers kind of fight to the death over who has control of the navigation controller at any given moment. And you also run into a problem where you've got to pass context along between your view controllers. If they're the ones that are dictating, okay, I'm in this state, and when the user taps this button, then they can go to this screen, or they might go back to another one. They've got to constantly pass context between each other. The way this is defined, the view controllers have no concept of where they are in the flow. They're just given enough information to populate themselves, and they communicate back up through a delegate when the user has entered the required data. But all the good things must come to an end. So this worked exactly the way I was asked to build it, based on the requirements I was given. But as you all know, requirements change. And so yeah, he was like, well, okay, that works the way we wanted it to, but users need the ability to reschedule an appointment. And rescheduling basically just means that they start off with an appointment that's got like a doctor and a location and an appointment type, but the only thing they can change is when they want the appointment to take place. They can't go back and change who or where the appointment takes place. And so I was like, okay, that's all right. I'm using a state machine, so all I need to go back and try to figure this out. Maybe I can add some new transitions. And I soon realized that then I was going to have like a states within states, and it just, because I didn't want the user to be able, essentially, I don't want the user to go back to the whom state, because that's where they can edit who and where an appointment is. And then I realized, wait, I don't need to change this state machine. I can just create a whole other state machine, which is much simpler, because in this particular system, when the user reschedules, they can only reschedule using the indirect path. And so when the wizard is initialized with a schedule, it's also initialized with a different state machine. And the actual views in the wizard don't change. Right? The flows between them don't change, because that's all dictated by a state machine. And so in this case, when they're creating a new appointment request, it goes through the larger state machine. But when they're requesting a change, I just initialize it with a different state machine that's much simpler. So what I thought was going to take me weeks to implement only took me about 15 minutes once I sat down and realized, oh, yeah, that's the flexibility I get from using state machines. Okay, and finally, session management. All right, so if anyone's built apps that require login, you'll know that you seem like you're always having to juggle between these states where you can't launch directly into your kind of main application flow, right? There might be a situation where the user has to log in first, and if they launch the app, they're not logged in, you can't take them to the home screen, you got to take them to a login screen, you got to wait for them to authenticate, then once they authenticate, then they can go into the actual app, and then, you know, who knows what happens. There might be a time where they stop using the app, session times out or something like that. So at any point, they can go from the like using the app back to the unauthenticated state. And if you try to handle that complexity across all of your view controllers, be able to handle that at any, you know, that arbitrary state change, it's going to get really difficult. So what I did was I took a step back and implemented a state machine to manage this for me. So the app initializes. The user, in this particular app, the user has to log in every time. So they immediately go into an unauthenticated state. Depending on how they've set up their login, they can either log in manually and enter their username and password, or maybe they've set up PIN and Touch ID. So there are a couple of different ways that they can authenticate. Once they've authenticated, they go into this preloading state, which is where we cache some necessary information that has to exist before we can let them into kind of the full app. And then once that data is finished preloading, then they're running, and they're using the app. At any point in time, like if they don't use the app for a little while, there's a security feature that expires their session. So even though they're running, if they haven't used it in a while, the app falls back into an expired session. The expired cleans up things it needs to, and then it shuffles them back into an authenticated state. And so all of this happens outside of the knowledge of the view controllers within the app itself. This particular implementation was done using notifications. So as the system, there's like a service bus that handles authentication. So once the user is authenticated, it just sends out a notification. There's another object that manages the state machine, and as the state machine travels between these different states, it knows how to kind of pull the puppet strings of the view controllers and determine, okay, whose turn is it to be the kind of the root view controller right now? Is it the stack of screens that define authentication, or is it the actual application view controller itself? So, all right, so let's run through it really quick. I initialize, I'm unauthenticated, so I'm going to say, okay, this person's got PIN and Touch ID enabled, but you know, maybe they want to cancel, maybe they do want to enter that. So that's a valid transition. They can cancel out of that and go to a manual login. They log in successfully, preloading and caching the data, and now they're running and they're in the application. Great. So again, with the changes, okay, you told me this is the way you wanted it to work, and now you're telling me no, need you to change it. Because there's actually now this feature where users can log in elsewhere and then launch the app with a token, and we don't want to force them to go through logging again because they've already logged in somewhere else. Well, okay, that's all right. I've already done this. I did this before with the appointment wizard, so I could just do that again, right? I could create a different state machine to handle this case. But as I looked at it closer, I realized, actually, I don't need a whole other state machine to do this, because all that's really happening is I'm given access to, let's call it a web token. It's a token I need to access my API. I'm actually getting it earlier than I expect, because down here, what's happening under the covers is when you go from this manual authentication or PIN and Touch ID authentication, that's the point at which a web token is typically generated. So really, all I need to do is specify a way where the user, if I have a web token, I can bypass these states and go straight to preload. So that's exactly what I did. I changed my state machine so that I can initialize it, or the one that manages my state machine, I should say. If it's initialized with a web token, and I made a modification to the valid state, right, the valid transition. So now it's valid for me to transition from the initial state directly to the preloading state. And when that happens, the web token is passed along. So the preloading state has no concept of where that token came from. It just knows when I'm starting up, I'm going to be fetching data. I need that web token. It doesn't matter to whether it came from manual pitch ID or touch ID authentication, or if it came from an external authentication source. And so just by adding that one transition and by handling kind of a new initialization state where I'm given the token up front, I was able to, make that change in a matter of minutes. So now the current state, I'm going straight from initial into the preloading state. So, once again, it was something I thought was going to take me a couple of days to get around, but once I stepped back and looked at it, I realized the state machine that I already had was 99% of the way there. All right. So today I hope I've kind of described or defended the position of managing state with intent and how it can be useful in your applications, how valuable it can be, not only for making your application more manageable, making it more maintainable, but also helping to remove ambiguity from your app, because it's not, you have to kind of think long term. It's not just about the solution I can get out today. It's about the solution that I can get out today that I'll be able to understand tomorrow and the next week. The solution that a new person on the team coming in is going to be able to understand quickly and not go in and make changes that stomps all over the application and breaks things. So state machines is something that's going to help us be obvious and have intent, and have that intent reflected in the architecture of our applications. And if you do this, your future self will thank you. If you want to learn more about this concept, like I said, the key state machine class that I'm using right now came straight out of this Apple session from last year. Sarush has a great blog, if you're not familiar with it. He doesn't necessarily talk specifically about using state machines, but his blog brings up a lot of great concepts about things that you need to consider in your application architecture. Handling state is one of them. He has various ways of doing that, but I've always found his blog to be very enlightening and helped me think of different ways to approach problems that I run into a lot. All right, well, thanks for coming. This is me. If you have any questions, you can reach out to me at any of these channels. I try to keep a copy of all my talks up on my website there. But if anybody has any questions, I guess we've got a little bit of extra time.
So on the first view you went through with the different states, and you said that each one of your views, when you transition from state, conforms to a delegate that the state machine then refers back to.
Mm-hmm.
Does every one of inside that delegate, those couple of delegate methods you had up on the screen, does each one of those have to track what, like case, string, do something? If it's this string, do something else. How do you do that? How do you separate each transition back on the delegate side?
Specifically in the for the appointment one, or
for any transition, you have to go from when your state machine says, "Okay, I've transitioned.
Oh,
here's the delegate call
right.
that gets fired." How do you then do something correct down back?
Okay. So one of the methods that I didn't show. So some of the signature methods that state machine will search for, it will also do like will transition to. And so if you override will transition to state, that's before the state has changed. So inside of that, you can query, well, what's the state right now? So that'll let you know if you need to do different. So specifically in my appointment wizard, depending on which states I was switching between, that would dictate how I would push and pop things off my view controller, because as a user was going deeper, I'm pulling stuff in this way, but if they go back to the beginning, I need to know that so that I can simulate them going back in the stack.
In that exact example, are you using the storyboard, or are you loading things in code there?
So I do use storyboard, but the storyboard is just there to define a container view controller, and then I have these other ones that are embedded segues, but my wizard is the one that controls which of those embedded segues occur and when they do. So the view controllers themselves don't know anything about each other. So if I wanted to, I could go in and rewire the ordering at any point, and I wouldn't have to change a view controller. All the way in the back.
So I was wondering with the whole appointments thing, the requirement that you had to have those state machines, right?
Mm-hmm.
So I was wondering if you had those requirements beforehand, would you have still ended up with two different state machines?
That's a good question. So yeah, maybe I shouldn't be beating up on my project manager, because I do think that the solution I came up with was the better, because if I do think that the way that you would manage the rescheduling versus creating one from new, in retrospect, is better served by having separate state machines, because they represent, there are transitions that are allowed in one and not the other, and that would have been difficult, because you can't have conditional. To have a true state machine, you shouldn't have any transitions that are conditional. You know, if a transition is defined, you should be able to do it all the time, right? And by having separate state machines and utilizing one or the other depending on the context, it let me get around that. But yeah, that's a great question.
Have you ever implemented a state machine where the states themselves are a hierarchy of classes that actually perform the transitions to the next state themselves, even
Yes.
to the point where they instantiate the next view controller?
Yes, so in the appointment view controller, like some of the states require multiple items to be entered before they are valid. And so when, say, you enter the whom state, that's a traditional table view controller, because I figured the kind of the whom state and picking like which doctor, which location, those were always going to be tied together. And so when you enter that state, you're actually using kind of a regular table view with a navigation controller, but you always come back to that home screen, which is managed by that overall wizard.
But the states themselves are performing those.
No, in that particular case, the states were not. So I probably could have further defined it that way and done it that way, but
Yeah,
for this particular one,
I've implemented state machines quite often where the states themselves are not just string names of the states and arrays of next possible transitions, but the states are classes that actually know what circumstances they should instantiate the next view controller under.
right. And that's a technique that is covered in the blog that I mentioned. That's what he likes to do, is encapsulate state as an object that you instantiate, which is another, I mean, that's certainly just a feasible implementation as this one. What I like about this one is that I like how I can go to one place to see the overall architecture. And when you encapsulate everything, you don't have someone else, one place you can go to see all that.